Hi, the next podcast in the series is going to be talking about three items: point, ray, and plane. So when we talk about the particular definitions that go along with this, let me quick change to my arrow here. So when we are talking about a point is basically a speck in space. It's represented by a dot, or you can think of the coordinate plane, because we've always done and been graphing points for quite some time. When we are talking about the definition of a plane is a flat surface determined by three non-collinear points. Make sure you write down these two definitions. The plane with the non-collinear points, we will get into that in just a minute. We will also talk more about collinear and coplanar in the next podcast. We also use symbols for planes and for points and for rays. For points, it's just really simple. If you have, this is what it would look like, especially on the coordinate plane, and we just call it point A. Make sure that you use capital letters because that is super duper important. So we always use capital letters in geometry. We do not use lowercase letters. Array's basic definition, and the definition basically is it starts from a point, a starting point, and it extends in one direction infinitely. And so from that kind of idea, it's kind of like a flashlight. You know, the light is originating from the flashlight and it keeps going in one direction. Unlike a segment or a line, a ray can only be named one way. You have to name it with wherever the ending point is first. So wherever the dot is, that's the starting point. It does not necessarily need to be on the left-hand side. So D, then E, and then notice I put a little mini ray symbol. Again, notice no dots are on there. To show you again another example, if you look down here, notice it's a different kind of ray. And notice the focus of it is not at D this time, it's at E. So since E is the starting point, that's where the flashlight's going to shine, that direction. Therefore, E would have to go first and then D with the ray symbol. Notice that even if the ray is going to the left, the symbol is still going to the right. So it's just kind of how we write things in geometry. If it's a plane, by the way, that's going to be named a little bit differently. So for a ray, we would have like AB, that would be a ray. GB would be a ray. This one would be a bad one, and hopefully you can figure out why. And the reason is because the ray is going the wrong way. So it could be fixed. So this one really shouldn't fit anywhere. And then of course, this would be a picture of a ray as well. So by sorting them into categories, so now you should hopefully see some distinguishing factors between lines, segments, and rays. If I wanted to name a ray in here, you could go from C to F and put that particular mark there. So like you would discount this part of C here for the ray. So you could have CF, because F obviously it still extends one direction. Or if you wanted to discount this part and keep this part and include that part again, you could have FC, and that would be a different ray. Notice again, even if they're going different directions, my little ray symbol always goes to the right. For points, it's very, very simple. You can just use capital letters. So you don't need to even write point. So like if I want to name a point, I could just say A, or I could say B. How we separate them is we use commas. So technically for points, I mean, you could name anything on here. We have, you know, A, B, C, D, E, F, so forth. So there's many points in the picture. The big thing is don't put the letters together. When you're naming points, you have to put commas in between because that's going to distinguish it from anything else. Otherwise, it's going to look too much like a line or a ray. And when we start talking a little bit about planes, planes is a flat surface. So for a flat surface, that's what's going to determine a plane. It's determined by what we call three non-collinear points. And we're going to get to that in just a little bit. For example, this particular shape would be built by many planes, because a plane, again, is a flat surface. And if this is a cube, you would have 6 planes in here. So now if I go back to some of these examples on whether they're best modeled by a point, line, or plane, a star in the sky would best be modeled by a point. An ice skating rink, it's a flat surface, so it would be a plane. A telephone wire strung between poles. Technically, it depends on your thought of, how it works. They keep continuing between poles, so therefore that would be considered a line. And that's basically about point, line, and plane.